Right, so today you will learn about solving equations involving surds. Okay, so this is the last topic for chapter 3 under indices and surds. So how do we actually solve equations that involve surds? Okay, I'm going to give you three particular cases, right? So the first case is that if you notice, it's only the coefficients that are in surd form. Okay, so this is just a simple equation that involves surd. So what we can do is to actually just combine your like terms. So in this case, the square root of 5x, okay, and the square root of 2x are like terms. So I'm going to transfer this to the left side of your equation, and that will give us equal to square root of 7. And then because x is a common factor, then you can factorize that and you are left with square root of 5 minus square root of 2 is equal to square root of 7. And since you are solving for x, that means we need to isolate your x. So we're gonna divide the whole equation by square root of 5 minus square root of 2. So some of you might stop right here, but actually this is not the final answer since the denominator contains a surd. So recall from the previous video, what you need to do is to rationalize. And when we rationalize, we have to multiply by the conjugate. So if it's subtraction, then that becomes addition. So that's square root of 5 plus square root of 2. So therefore, your x will be square root of 7, okay, times square root of 5 plus square root of 2. The denominator, recall again the difference of two squares. So when you multiply the number by its conjugate, it's the same as the difference of two squares. That means we're going to square each of the term. All right, so therefore your x will be, so square root of 7 times square root of 5 is just equal to square root of 35 plus square root of 14, right? Divided by square root of 5 square is just 5 minus 2, and that gives us a positive 3. All right, so for this example, you notice that the left-hand side of your equation is just a square root of x, while the other side is x. So these terms are not common to each other. So how are we going to isolate, or how are we going to solve x for this case? Notice that the square root of x is just x to the power of 1/2, isn't it? Okay, and that gives us a 2x minus 6. So there is no way that we can actually isolate x here. Compare it to the previous example that we have, we can easily isolate x. But for this one, we really can't. So how are we going to solve for this type of equation? Now remember that you have to recall, okay, that your x, right, is just equal to x power of 1/2 square, isn't it? So if you're gonna square your x to the power of 1/2, that gives you, right? That gives you x. So what we're going to do is we're going to square both sides of the equation. Okay, that's how we can isolate, or that's how we can remove the square root actually. So that gives us, this one will just be x is equal to 2x minus 6 squared. Expand this expression, and that gives us 4x squared minus, this is 2x times 6 is negative 12 times 2 is 24x. 6 squared is positive 36. So in other words, that becomes 4x squared minus 24x. So I need to transfer this x to the other side. That will become minus x plus 36 is equal to 0. Remember that when you're dealing with a quadratic equation, you need to make one side of the equation equal to 0. That's how we can solve for the quadratic. So that gives us 4x squared minus 25x plus 36 is equal to 0. Okay, and now we're going to need to factorize this. So think of the factors of this expression. So what will that be? So this can be factored as x minus, so that means that's 4x. And this one is just x. So this is x minus 4. And then x minus 9, I think. Isn't it? So that will give you 4x squared minus 9 minus 16. That gives you negative 25. Okay, plus 36 is equal to 0. So therefore, your x values are 9 over 4. And for this one, x is equal to positive 4. Okay, so these are the solutions for your equation. Okay, so now what we can do, the problem with surds is that we have what we call your extraneous roots. When we say extraneous roots, these are the values of x that we found that will not satisfy the given equation. So that means we actually need to do the checking. So when x is equal to 9 over 4, this gives us the right side is square root of 9 over 4. Is this equal to, there's a question mark, 2 times 9 over 4 minus 6. So this gives us 3 over 2. 9 over 4 is 18 over 4 minus 6. So what is 18 over 4 minus 6? That gives us, so 3 over 2 is, this is a question mark, and this is equal to negative 3 over 2. So in this case, these two are not the same. So therefore, x equals 9 over 4 is an extraneous root, right? And what about when x is equal to 4? So that is square root of 4 is equal to 2 times 4 minus 6. Square root of 4 is just 2, and this is just 2. So in this case, okay, let me change it. In this case, only this is the solution to your equation, right? So don't forget about this term, extraneous roots. So we only have extraneous roots when we are dealing with equations involving surds, okay? Right, now what about for this other one? So this is the third case. So if you notice, it looks a bit complicated. The first term is in surd, the second term is also in surd, and it's equal to 1. So we can make things simple by isolating one of the surds. So what I'm trying to say is that only one term that involves surd should be on one side of the equation. In this case, we have 2, right, on the left side. So what we can do is we're going to transfer one of them to the right side of your equation. So it will make things easier for us. So don't forget about this. Okay? So if you notice, it's just a square root. So that means we can easily just square the whole thing, isn't it? So square root of 3x plus 4 squared, that only gives us 3x plus 4, right? And the right side of your equation, you're going to square this. That means expanded form will be 1 plus. So this is 2 square root of 2x plus 1. And then the square of this is just 2x plus 1. Okay. And so now we can transfer the common term. So that gives us 3x plus 2 becomes a minus 2x plus 4. 1 plus 1 gives us a 2. We transfer it to the left side. That gives us a minus 2. And that's equal to 2 square root of 2x plus 1. Okay, and so therefore, this is just x plus 2 is equal to 2 square root of 2x plus 1. So how do we get rid of the square root again? So what we will do is we're going to square the whole equation. So square this again, and that will give us x squared plus 4x plus 4 is equal to 4 times. So we're going to square this as well. That gives us only 2x plus 1. Okay, so therefore that gives you x squared plus 4x plus 4 is 8x plus 4. And then combine the like terms. So that gives us x squared minus 4x. 4 minus 4 gives you 0, so that will be, we only have this. So that means we can factorize x. X minus 4 is equal to 0. So the values of x are x equals 0 and x equals 4. Now let us do the checking. When x equals 0, what do we get? So that's square root of 4 minus square root of 1. Is it equal to 1? So that gives us 2 minus 1, question mark, is equal to 1. So that's 1 is equal to 1, okay? And when x is equal to 4, let us also check about that. So that's square root of 3 times 4 is 12. 12 plus 4 is 16. Minus square root of 2 times 4 is 8. Plus 1 is 9. Is this equal to 1? So that gives us 4 minus 3. Is it equal to 1? And yes, they are the same. So therefore, for this case, we have 2 possible solutions. Okay, so let's have this question from 0606 specimen paper for 2020. Okay, so in this case, you notice that you're given with a trapezium, right? And you're given with the side of AD, the first base, which is DC, the second base, which is your AB, and it is given that AX is the height in the sense that AX is perpendicular to the base, okay? So you're given that the area is this. And we're gonna look for the value of X. What is X in this case? Okay, so what we can do is, of course, we have to make use of the area for your trapezium, which is 1/2, right? B1, first base, plus second base, times the height, correct? If you notice, the first base and the second base are all given, but the height isn't. So we don't know what this is. But ADX, triangle ADX, is a right angled triangle. So that means we can actually use your Pythagoras Theorem. So by Pythagoras Theorem, we know that the sum of the square of the bases is equal to the square of the hypotenuse. So that gives us a h square is equal to 49 minus 4. And so therefore, h is square root of 45, which is 3 square root of 5. So we now have the height, and we're going to use the area. So that gives us 1/2. First base is 2 plus x, right? Second base is 4 plus sud 5. And the height is 3 square root of 5 is equal to, this, since this is the area and we're given with the area, which is 15 times sud 5 plus 2. Okay, so we're going to simplify this first. 2 plus 4 gives you a 6, so that's x plus 6 plus square root of 5 times 3 square root of 5, okay, is equal to 15 square root of 5 plus 2. We can transfer 1/2 in the sense that this gives us x plus 6 plus square root of 5. Okay, and this is 3 square root of 5. And this gives us 30 bracket square root of 5 plus 2. Okay, so we're going to need to isolate x. So the next thing we can remove is the 3 square root of 5. That means we're going to need to divide the whole thing by 3 square root of 5. Okay, so now we have x plus 6 plus square root of 5 is equal to, since this is just division, so 30 divided 3 gives you only a 10. So that's 10 bracket square root of 5 plus 2 divided by, now we only have square root of 5, right? And since this is just a single term in the denominator, When we wanted to rationalize it, we just multiply by itself. Okay, so that gives us 10 bracket square root of 5 times square root of 5 is just 5. 2 times square root of 5 is 2 square root of 5. Okay, divided by 5. So therefore, x plus 6 square root of 5, we can divide 10 and 5, and that gives us a 2. 5 plus 2 third 5. Okay, oh, so there should be a plus here. So if you want to remove or if you want to isolate x, we can transfer 6 and square root of 5 to the right side. But first distribute 2, so that gives us a 10 plus 4 square root of 5 minus 6 minus square root of 5. So therefore, the x value is just equal to 4 plus 3 square root of 5. So this is x. And that means A is equal to 4 and B is equal to 5.